Hi, today we're going to talk about set sensor network user interfaces. And basically, what they are actually what you can describe as Bluetooth or Z-Wave and other types of communicating tools. Like, for example, a real quick example would be the Bluetooth headset communicating to your phone. It's interpersonal network. So some of these are subnetworks that run on the bandwidth that the your portable phones work on inside the house, not your cell phone, but a portable phone in the home, a cordless phone, if you want to go there. Uh, Many applications to these sensor network user interfaces are, for example, they have a new thing where you can walk up to your house and the door senses your phone as long as the Bluetooth is on, and it knows that it's you, and it automatically opens the door for you. So you've just removed the whole use of not having an actual physical key to open the door. Uh, the other uses for sensor network user interface is for the appliance in the house to actually communicate with each other. You actually connect them into a power plug that works on Z-Wave, and they basically communicate to each other. And that way, you can actually control when they come on, when they come off, or give your appearance. You can dim them down or slow down the amount of power or fuel that they're using whenever you're using said items in the house that are connected to these network items. Now, I'm going to give you a demonstration today on the CFDO cubes, not only the actual cubes themselves, but the SDK also. So, part of my desk here. So basically what we have here is you have the main head unit, and you have, at this point, 6 CFDO cubes. Now you can actually code stuff for these cubes, okay? Uh, Being games, it's what they want to call this is intelligent play. And the cool thing about these CFDO cubes, in the documentation that I have, they are pressable, so they're clickable. Okay, they can tell where how close they are to each other via a wireless signal. They also have like a infrared way to communicate with each other. Obviously, we can't see infrared, but they definitely have tilt sensors in them and everything else. And I'm going to actually explain how that all works if I can get them to turn on. So here they are. They're turning on right now by the press of the button on the main console. Now, actually, this is where your most of your programming information is stored, and it's wirely sent to the cubes. Now, as you if you can see here, we've got a game, and the way we can select the game is there's a couple of games that are already on it. So by tilting, it moves the menu through, and it works pretty well actually. So one of the coolest games that I think is Sandwich Kingdom, which is pretty amazing. I'm gonna go ahead and select that. So now that I've selected the game, you sort of get your little loading screen there, and it loads it onto the CFDOs. Now the max that these units can go up to is 12, and it takes a while for it to load. But for example, if there's a game that only uses so many, but you have all your cubes on, you'll get these little dead screens, basically telling you that, hey, guess what? You don't need these to play the game. So using the main tile here. Now this is basically like a maze puzzle game where you have to build a road for the person to go through. So I'm just gonna hit continue here as it loads. Also, the audio comes out of this device also. So there's a little slider here for the audio. So I'm sure you can hear that. So as you start to put the pieces together, it actually starts building the world. So this is telling me that this is not what it wants. So I'm trying to build the the world here. It's really cool because you can tell it's telling you basically, hey, this doesn't go there. So as of right now, it just totally changed the way I'm playing because depending on where I put what, so I've got all these like maze possibilities here, and I can't have my guy move forward until I actually figure this out. So it includes a lot of problem-solving skills and hands-on. And the great thing about this is this can be coded in either C++ or C Sharp, and by doing you can also do that with the SDK. They actually provide an SDK, which I'm going to give you a quick overview of, and just make like a quick shell of a game so you can see that it actually works. And you can move on from there. I've also got the documentation that I'm going to be uploading with this video, but that's just one game right there. Let me show you another game. So actually hitting this button will let me go back if I want to exit game. So here I am. I'm going to quit. I pressed it. It reacts. I'm going to choose a simpler game called Chroma Splash. As you can see, it's loading. Now, like I said before, you can specify the amount of tiles in the programming, and this game only uses 3 tiles. So I've chosen a puzzle, one that I was working on prior. So the way it works with this is, but you have to match the colors and you can move them around, and when you hit the cubes together, those light colors will disappear, and then you can actually shift whatever's left by tilting the boxes. Now there's also a YouTube video where I'm also putting on the reference page of my documentation that shows how a teacher actually used the cubes. He invented his own program on the cubes that by clicking the cubes gives instructions to a little Lego robot, and it shows the kids how to program, obviously with pictures. But alright, this is taking too long, so I'm gonna go ahead and let that run. But let me go ahead and go to the programming here. So once you have downloaded the SDK and you extract it, you're gonna go to the file here and just double click on this command shell. And that brings up the SDK. And I'm just gonna bring up a good example that they already have, which is called stars. And I'm going to make the file, which is basically compile, and then which I've already done. That's why it's giving me the done. There's nothing to be done, and then I'm going to run it. Just give me a second here. So I'm looking for the stars.elf file to run through the simulator. You can see it uses a 3D graphics exit the simulator. You just go over like a quick and easy shell that I did. Just like basically a scratch game. And really all you need to do is make 3 files. So in the main.cpp, you just need a void main to give it an regular C++. And this actually, this unsigned number right here is what something that you need that basically tells you how many cubes you're supposed to be using. So right here, as you can see, I'm just going to use 2 just like I did in stars. I have game assets that are available here with the metadata. I've given the name of the game, Scratch, the build package, how many cubes, and an icon. And if you can look, the icon that I made, it's just a PNG that says icon. So it's 96 by 96. You have to be very, very efficient when writing code for the SIFTIO because you've only got so much space. So music is usually about 8-bit. Your PNG files have to be very small, very condensed, and your code has to be very, very efficient. You'll want it to load fast, and you want it to be able to execute fast also. So once you make your shell of a main file, you make a make file, and just basically where it says app here, you will put in your app name and leave all of this stuff the same. And then in your Lua, your assets.lua file, game assets equals group, icon equals icon image, and that will give you the icon. So that way when you execute it, so here I'm just going to cd out of examples. Cd into scratch game. I'm going to do my make just to make sure it's all compiled. Then I'm going to do the SIFTU later. When you do the compilation, it makes all those other files that are necessary for the SDK to execute. And then once that compiled file is good, you can actually push it out to the SIFTIO cubes. So the name of my game is Scratch Game. And you want .elf. It's basically the executable. So as you can see here, there's this is going to be the dead cube. And there's my game with the icon. Choose the icon. And it didn't do anything because I don't have any actions listed for after the icon. But for a graphical user interface, you really don't need the cubes, and you can also zoom in and out so you can see your play area. You can add more cubes, obviously. Minimum is always going to start up with in this presentation. Or configuration is 3 is always the minimum that's going to show up in the emulator. You can go all the way up to 12. And so now going back, since the game loaded, here, so you can see I got 2 different colors coming together, right? Bam, exploded. Now, if you notice, I can also shift where everything goes. It's giving me an error right now because you know what, I messed up and I wouldn't be able to clear the game because of that. But because I had already tilted the tiles in the direction that I wanted to. So you got to be smart, start over again, and there it is. So I'm just going to do it this way. Then I can decide how it's going to go. As you can see, I'm not really good at this game. But notice that this game only uses 3 tiles, and the other tiles that are on are dead tiles. The cool thing is about these things too, they're making a new version that runs off a rechargeable source, but they only use AAAs. The whole system uses AAAs, so it's pretty convenient. I have a recharging system for AAAs, and I think it's an awesome system. Now to just shut it off, I just hold this button here, and I get a little countdown. and it's gone. But this is what's going to become a new wave of playing video games, since now we have the 3DS that detects when somebody's close to you, or the PSP that does that, or the PS Vita that does that with the Near. This whole huge interconnectivity. Well, that's my presentation. If you have any questions, feel free to ask any. And on top of that, I will be posting the reference, the Word document with all the references to where you can go to get a tutorial, where you can download the SDK, and towards the videos that actually show you how some people have actually implemented these games. Thank you.